Hi children, very good morning to you all. Today I'm going to start a new chapter, that is chapter 12 of your science textbook, friction. So it is very much linked or related to your 11th chapter, force and pressure, right? So have you learned anything about friction in force and pressure chapter? Yes, we had learned something about friction in that chapter, right? So let us just quickly recapitulate what all we learned about friction in our force and pressure chapter. So what is friction? So we learned this under the heading contact forces under the chapter in that chapter of force and pressure, right? So what is a contact force? The force is exerted here by the physical contact between the surfaces, between the objects, right? So it's an example of a contact force. And what is friction? Already I explained to you about the net force acting on a block in one of the lessons, in one of the video lessons, right? So when a block is moved by applying certain force in newtons, certain amount of force when it is applied to the block, what will happen? It will move or it may not move according to or depending upon the net force that is acting on the block, I said. Right. So, what are the forces which are acting on the block? We have seen this in our force and pressure chapter, that not just the force that you are applying, but there are some other forces which will be acting on the block. Can you tell me? Yes, it is nothing but in the opposite direction. What is the force that is acting in the opposite direction called? That is nothing but friction, right? Apart from the normal forces that are exerted on the block, that is by the ground and by the block, there is one more force that is acting in opposite direction, and that is nothing but friction, right? So today we are going to learn very basic things about friction. I want you to go through the textbook once again and read a few pages of the chapter friction. It's a very interesting lesson, children, and I'm sure that you are going to learn a lot from this small but yet very interesting chapter. So coming to the definition of friction, I can say that it is what is friction? Is it a kind of force only, children? Yes, it is contact force, right? It is a form of force only. So it is a force that is acting in a direction opposite to the applied force. That is one definition of friction. It is a force that acts in a direction opposite to the force applied, and it is basically a contact force. So that is one definition of friction. There is one more definition which is more appropriate, children. It is something that resists the free motion of a body. It is something that resists or obstructs. It is acting in an opposite direction, right? Imagine yourself riding on a bicycle on a windy day. The wind is flowing in an opposite direction to your pedaling direction, to your riding direction. So you experience a lot of force. You have to pedal more harder in order to move, isn't it? So what is happening there? It is nothing but the force is acting in an opposite direction. You are pedaling in one direction and the force of wind is acting in an opposite direction. We can say that you are experiencing the friction of wind. Did you understand? So what is happening here? Are you able to move freely? No, it is not happening. You are actually working harder to move forward, right? So it is resisting. It is causing some difficulty for the motion of the object or a body. So this is something that resists the motion of a body, and it acts in a which direction, children? Always friction acts in an opposite direction. So this is more appropriate definition, and because it is a contact force, there has to be a contact between the body. Okay. So what is the cause of friction? So if you see here, these are the two surfaces, one surface of one body and another surface. If you see this particular example, this portion is actually zoomed. Okay, you can see that this small portion, surface 1 and floor, the block and the floor, this portion is actually zoomed. So you can see here that surface 1 and surface 2, no matter, they may look like smooth surfaces, but at a microscopical level, you can see that these surfaces are not actually smooth. They have microscopic, zigzag like surface, like what you can say, jagged edges. Okay, they don't have smooth surfaces. Instead of that, they have what you call kind of hills and valleys. They say hills and valleys. So it is not actually smooth. Same is the case with the other surface also. They have microscopic zigzag like pattern. So that means they are not even. Okay. So because of these two, when these two surfaces come in contact, and you can understand that because of these jagged surfaces, they are unable to move freely. You can see that they get interlocked or tangled, or what you call interlocked between. There is some interlocking happening, and because of which the free movement is not possible. So did you understand what is the cause of friction? It is mainly due to the uneven surfaces, or what you call jagged or zigzag like surfaces, uneven surfaces or rough surfaces, because of which friction is caused. Okay. Now coming to the units of friction, we all know that it is another kind of force only. It is nothing but force only. So what is the unit of force, children? SI unit of force, it is nothing but newtons only, right? So friction is also measured in terms of newtons. Now you tell me, is it a vector quantity or a scalar quantity? Already we have learnt about scalar quantities and vector quantities in our last chapter, right? So tell me, what is friction? Does it have magnitude? Yes, it has magnitude. How much of how much amount of friction that can be measured? It has a magnitude, or it has a value. And tell me direction. Yes, it has a direction, because it moves in a direction opposite to the force. That means it is exerted in a direction opposite to the direction of the force. So it has both magnitude and direction. So what do you infer? It is a vector quantity. We all know that force is also a vector quantity. Friction is also a force. So it is also a vector quantity. And coming to the units, again the same units as of force only. Okay. So friction is always present whenever two surfaces are in contact with each other. Simple example I'll tell you, children. Just rub both your palms together. Rub both palms together. You can see that there are very fine lines on your palms, because of which there is friction, right? So when you just repeatedly do like this, what happens? What is produced? You feel that your palms are getting warmer, right? So by this we can infer that friction results in the production of heat. It results in the production of heat, children. Okay. Now do this, try this again by sprinkling some talcum powder or by applying some oil, and rub again. Do you get the same amount of warmth again? No. That means by applying talcum powder or oil, what are you doing? You are reducing the friction between the two surfaces. So actually the surface is like this. When you apply some talcum powder or oil, what happens? That goes and occupies these places, isn't it? Making it now appear smooth, right? This is now become smoother now. So when there are no irregularities present, when there are no uneven surface present, when there is no such irregularities present, then what happens? Interlocking also becomes lesser, so that lesser friction is observed. That is the reason why you apply some talcum powder. Very smoothly it just slides over, isn't it? So that is about friction, children. In today's class, I have just given you an introduction to friction. There is more to learn from this chapter, and so go through the lesson carefully in the textbook, children. It's just an introduction. Please go through the various activities that are given in the textbook and try and understand. Even I am going to explain them. Okay? Thank you.